Look at this patch of sky. It is smaller than a grain of sand held at arm's length. A piece of the dark so tiny you could hide it behind a single pixel on your screen. Hubble stared into it for days, and inside that almost nothing, it found thousands of galaxies, each one a city of hundreds of billions of stars. We called it the Deep Field, and it is one of the most important images humanity has ever taken. It is also, quietly, the problem. Because think about what it took. Days of the most valuable telescope in the world to capture one grain of sand. To photograph the entire sky at that quality, one narrow window at a time, Hubble would need far longer than the universe has existed. We built a machine that could see almost anything, and then found it could only ever look at the cosmos through a straw. In 4 weeks, that ends. On the 30th of August, 2026, NASA launches a telescope with the same eye as Hubble, and a view 100 times wider. It is called the Nancy Grace Roman Space Telescope, named after the woman who fought to build Hubble in the first place. And by the end of this video, that wider view is going to lead us all the way to a question hiding at the very edge of our own solar system. A question we have never been able to answer, until, perhaps, now. Let me show you what 100 times wider really means, because it is not what most people assume. Here is the first surprise. Roman is not more powerful than Hubble in the way you would expect. It does not see deeper. It does not see sharper. It carries a mirror exactly the same size as Hubble's, 2.4 meters across. Point both telescopes at the same star, and you would struggle to tell their close-up images apart. On paper, they have the same eyesight. The difference is how much sky each one takes in at a single glance. Hubble's infrared camera captures a piece of sky less than 1% of the size of the full moon, a keyhole. Roman, using that same quality of vision, captures a piece of sky larger than the entire full moon in one shot. Its camera holds 300 megapixels, built from 18 separate detectors working as one, and a single Roman exposure contains the equivalent of about 100 Hubble images, stitched seamlessly together. Astronomers have a good way of describing the difference. Hubble studies the universe the way you would study a crowd, by looking very closely at one face, then another, then another. Roman photographs a huge section of the crowd at once, and every face is still in focus. And here is the comparison that makes it land. Our neighbor galaxy, Andromeda. To build one sharp mosaic of it, Hubble needed more than 400 separate images, captured and assembled over more than 3 years. Roman can photograph that same galaxy at the same detail in about 2 shots. More than 3 years of one of the greatest telescopes ever built, matched in a single afternoon. Across its whole survey, Roman will map the sky up to 1,000 times faster than Hubble. Not because it is a bigger eye, because it is a wider one. And that one change, the same sharpness spread across 100 times more sky, is the key to everything else. So let us follow that key, one step at a time, and watch each step grow larger than the last. Start with the galaxies themselves. Because Roman gathers so much sky so fast, it will not catalogue a few thousand of them. Over its mission, it is expected to measure the light of more than 1 billion galaxies, each one holding hundreds of billions of stars. In a single pointing at Andromeda, it can pick out more than 50 million individual stars, one by one. And because it sees in infrared, a light our eyes cannot register, it can look straight through the clouds of dust that hide so much of the universe, and trace how galaxies have grown across the last 10 billion years. We are about to stop studying the universe one object at a time and start taking a census of the whole thing. For all our telescopes, our own solar system still keeps secrets, and the strangest one sits right at its edge. For years, astronomers have tracked a small group of icy worlds far beyond Neptune, out in the cold, dark past Pluto. And their orbits do not quite make sense. They are tilted and stretched and clustered together, all leaning the same way, as though something massive is quietly herding them. Something we have never seen. The simplest explanation anyone has found is a hidden planet. Several times the mass of the Earth, circling the Sun so far out, perhaps hundreds of times farther than we are, that it is almost perfectly invisible. It already has a name, even though no one has ever confirmed it is real. Planet 9. The reason we have not found it is exactly the problem we opened with. A world that distant is unimaginably faint, reflecting almost no sunlight, and it could be hiding almost anywhere along a huge arc of sky. To find it, you would need a telescope that can search enormous areas, deeply, patiently, in infrared, where a cold and distant planet would give off the faintest glow. You would need, more or less, the exact machine we are about to launch. In fact, the hunt is already warming up. In recent surveys, astronomers have flagged faint candidate objects in old infrared data that could, just possibly, be it. None are confirmed. To pin them down, you need to search again, wider and deeper. Roman, working alongside the new Vera Rubin Observatory, is one of the best tools ever built for that job. It will not be pointed only at Planet 9, and it may not settle the question by itself. But, as it sweeps the sky, it will chart the outer solar system as never before, catching faint, slow-moving worlds at the very edge of the Sun's reach. If Planet 9 is real, this is the era we finally corner it. And if it is not, Roman will still uncover a whole hidden population of distant worlds we have never met. Think about what that would mean. Not a faint smudge in a distant galaxy, but a new major planet in our own Sun's family. The first found in almost 2 centuries. A world that has been out there through the whole of human history, while we simply could not see wide enough to catch it. Which brings us back to where we began. That first patch of sky. The grain of sand that Hubble stared into and found 1,000 galaxies. For more than 30 years, that was the bargain we accepted. We could see almost anything in the universe, as long as we only looked at a keyhole of it at a time. The sky was never empty. We simply could never take in enough of it at once to see what was truly there. In 4 weeks, on the 30th of August, that limit comes off. The same clear eye as Hubble opened 100 times wider, mapping 1 billion galaxies, chasing whatever most of the universe is made of, cataloguing new worlds by the thousand, and turning at last to look for the one that may be hiding in our own backyard. We are not about to get a sharper view of the universe, we are about to get a far bigger one. And we are finally going to see what has been sitting just outside the edge of the frame, the entire time. If you want to keep looking at the things most people never think to look at, subscribe, and the channel will bring the next one to you. A like tells us this was worth your time and ours, and helps the algorithm show it to someone else staring up at the same sky. And if you are not ready to leave the dark just yet, there is another world waiting on the screen now. One we were never supposed to find.